Welcome back! The time has come to tackle the last form component for this course, the base radio. Radio buttons in HTML have a very unique feature that we need to be aware of before we start building our components. They do not work as single elements like a checkbox would. Radio buttons instead live and work in a group that share a single state. Depending on this state, radio buttons inside a group either are active or inactive in relation to those in its own group. Because of this particular quirk in how radio elements work, our base radio component will also have another component to group them, the base radio group. We will tackle that in the next lesson. We will begin the lesson by crafting our base radio component. The goal is to have a flexible, reusable component that wraps a single instance of a radio input along with its label. As before, we will first create our component file baseradio.view inside the components folder. Then, copy the input label pair for one of our checkboxes from simpleform.view and paste it into the components template block. Next, we're going to first tackle the label. So let's go ahead and create our label prop. It will be of type of string and the default of an empty string. Let's now go to the template inside the label element. We will check with a BF to see if the label property has been set and use interpolation to render it. Now that the label is dynamic and bound, let's go ahead and make sure that our component can respond to vModel bindings. We will begin by creating our model value property. Notice that for the base radio, we have set the type of model value prop to be of string and number. This will tell View that this property can accept either strings or numeric values. When dealing with radio buttons, each button holds the value it represents in the set. For example, if you had a group of radio buttons to select your favorite pet, one radio button would represent dog and another would represent cat. It's common for these buttons to also represent numerical values. For example, when selecting a number of guests for a hotel room, or even Boolean values in their numeric format. Having said that, let's now try to figure out how to use the model value property in a radio element. Similarly to checkboxes, radio elements don't bind to the value property of the input, but instead to the checked property. However, in the particular case of radio elements, because they live in a group, we need to determine if this button is the one that is selected or not. Let's go back to our example to understand how. The model value of our base radio elements will contain the user's preference, so either cat, dog, or otter. In our right example, 1, 2, or 3. But we need to be able to tell this radio which one of these values it represents. In order to do this, we're going to add first a new property to the component, the value. Let's scroll down to our properties and add another one, the value. This time, the type will be also of string and number, but we're not going to set a default. Instead, we will set it to required. If this property is not set, View will issue a warning for us. A radio button does not make sense when there's not a value attached to it. And even further, if the user forgets to set it, it could end up with multiple radio buttons having the same value, which will be really problematic. So in order to know if our radio is checked, we will look to see if the model value is equal to the value. So that means that the user's preference, cat in this example, will either be equal to the radio's value or won't, checked or unchecked. Let's now go ahead and delete the old vModel binding. We will replace it with a checked binding where we check if model value is equal to the value property. Then replace the value binding with our new value property and delete the hard-coded name attribute. We're almost there. We now need to add the second part of our vModel contract, the emitting of update events. Radio buttons trigger change events when they become the selected option. So we're setting up a change event listener with our update model value emit. be sure to pay close attention to the payload of our emit. We are going to emit the value prop. We want our V-model recipient on the parent to hold the value of the currently selected radio button, and because the change event will only fire when the element makes the selected choice, we can safely fire props.value to update the parent about the newly selected option. Finally, because we removed the hard-coded name attribute, we need to make sure that the developer using this component is able to set attributes like name into our input. So we will use vbind attrs on our input, like we learned when we were building our base input component, to be able to allow this attribute injection into the correct element. Now that our component is ready, we can go back to our simple form.view and replace the two checkboxes with our shiny new base radio component. Let's navigate back to simple form and replace the first element. I will add a base radio instance. We will v-model it to event.pets, bind the value to 1, and set up the label property to yes. Finally, let's add the name attribute equal to pets. Let's do this one more time. Add the base radio instance, v-model it to event.pets, bind the value to 0, set the label property to no, and add the name attribute equal to pets so that it belongs to the same group as the one above. Let's now go over to the browser and check out if everything is working. You can see as I click around between the yes and no option that the pets binding of our form correctly changes between 1 and 0. As we've seen, radio buttons can sometimes be quirky and hard to work with, but we've made good progress into creating a solid base radio component. In our next lesson, we will take this a step further and create a base radio group component, which will simplify even further the creation of radio groups. See you there. So in this example, either cat, dog, or wow. Welcome back. In our last lesson, we created our final base form component for this course, the base radio. However, we left off with a component that is completely flexible and reusable, but sometimes a little hard to comprehend. For someone that is not familiar with the inner workings of a base radio, a group of them all pointing to the same V-model state can be confusing. Errors may also occur if someone forgets to add a name attribute to a certain part of a group. It would be better if we had a wrapping component that handled all the logic of managing the V-model connectors for our users, so that they only have to remember to do it once, as they do with most other components. And it's also easier to understand at a glance. Enter the base radio group. As we mentioned in the last lesson, it doesn't really make sense when radio buttons are by themselves, as they don't really provide the user with choice, which is a key feature of radio buttons. So you almost always want to provide at least 2 radios per each group, unless you're doing something like this. Having said that, since we always want to have our base radio elements grouped, it makes sense to create a component that contains the logic for the grouping. the base radio group. Let's dive right in. Let's start by going into our components folder and creating a new file, baseradiogroup.view, which will house our new component. This time, we won't copy-paste code from the demo form since we will need to do a little bit more custom work. In order to get started, we need to create a prop that will allow the user of this component to pass an array of options that they want to let the user choose from. We also want to make sure that we use the data inside of this new options prop to loop through the containing objects and create a new base radio component instance for each one. The option property will be an array of objects, and we will want each of the objects inside to hold at least two properties, the label and the value. In this example, you can see that the label good boy is being applied to the label of the radio element. The value is what we will bind to on the V model. Let's add another object to our example. As you can see, when the user selects a new radio from the group, the V model binding to selected pet will correctly change to the value of the second option. Let's go ahead and add our props object. Inside, we will add the options prop. Its type will be of array, and it will be required. It is important to remember to set the options property as required, since this component simply won't work without it. Let's go ahead and now add to our template the base radio loop. We will add a before declaration option in options. We will then set the key to the option value. We will set the label to the option label, and we will then set the value to the option value. As we learned in the last lesson, all radio groups are bound together as a group by the name property. All of the radios in a group need to have the same name so that the browser knows that they ought to be grouped together. So, let's go ahead and add our second prop, the name prop, and make sure it's correctly bound into our base radio components. Let's go ahead and add the name property into our props object. It will be of type string and required. Then we will bind the name property of our base radio loop to our name prop. Now that we are correctly looping through our radio components, you probably know what's coming next. It is time to allow for this component to handle vModel two-way binding. Like always, we'll add the model value prop first. Let's scroll down and add the model value prop. Its type will be of string and number. This time around, we're going to make the prop required, since radio groups without anything selected don't make much sense. There's not really a nothing selected state when using this type of form input. Let's now scroll up and bind the model value prop to each base radio element in the loop. Next, let's start listening to the update model value event of each of the base radio elements and emit it right back to the parent of the base radio group. We can now save the file, go back to simpleform.view, and replace the rpetsallowed section base radio elements with a brand new base radio group. We will set the vModel to event.pets, the name property to pets, and the options property to a pet options array that we will create in a minute. We can also get rid of this extra code now. Let's now scroll down all the way into our data and add the pet options array. We will add two objects to the array. The first one will be a label of yes and a value of 1. The second one will be a label of no and a value of 0. We can now go into the browser and bask in the glory of our not very nice looking group of radios. It looks like we're going to have to do some extra work to make it space correctly, but at least it's working. Before we replaced our base radio components in simple form view, they were each wrapped in a div. Because of the block nature of div tags, it separated them each in their own line. Our base radio component is agnostic to presentation. It's only an input and label tag in the end. It is our job as the users to determine how they must be presented in the screen. For our base radio group, I would like to create the possibility of the radios being aligned both horizontally and vertically. To keep it as simple as possible, all of this switching will be controlled by one single new prop, vertical. We will default the layout of the radios in our base radio group to horizontal, so this prop will be of type Boolean and default to false. It is a very common practice when creating components to set props that are meant to toggle on and off, also known as flags, to a default of false. That allows us to be able to set them to on with a very clear syntax on the instance of the component. For example, with our vertical prop, if the user wants to have their group laid out vertically, they would simply add the keyword to the instance, like in the example. Boolean props in Vue that are not specifically bound are assumed to be true. So in the above example, vertical is the same as vertical equal true. Let's go back to baseRadioGroup.vue and add our vertical prop and begin setting up for this new functionality. Scroll all the way down and add the vertical property. The type will be a Boolean, and the default will be false. Now, in order to use our vertical prop, we have to wrap our radio group loop in a component of its own. When the radios are horizontal, we want it to be a span, and when they are vertical, we will use a div. There are, of course, many ways to solve this particular problem, but this solution in particular allows me to show you how to leverage the power of component is for your dynamic form components. Let's scroll all the way to the beginning of the file again. We will begin by wrapping everything up in a component element and moving the before loop onto it. We will also bring the key property binding. Finally, don't forget to add the wrapping tag. Now we have to determine the logic for the is property of the component. Whatever string we pass into there will be what Vue uses when rendering the component. So if we set the is property to div, the wrapper component will be a div. And if we set it to span, it will of course be a span. Since this is not very complex logic, we can get away with leaving it all in the template. We will check if the vertical prop is true, and if so, it will be a div, and if not, it will be a span. Please notice that both the div and span are wrapped in single quotes since they must be strings. If we now go back to our simple form and set the vertical flag for our base radio group and check in the browser, everything seems to work as expected. Let's now go back to simpleform.vue. There is one more adjustment we need to make for the horizontal layout. The elements are sort of touching each other, so we need to add a bit of styling in order to separate them. First, we will remove the vertical flag, and we will go back to base radio group. Scroll all the way down and add a style block. We will add a horizontal CSS class and set the margin right to 20 pixels. Now we can scroll all the way up and add a class binding. In this class binding, we are using the object syntax to toggle the classes on and off. Whenever the condition not vertical evaluates to true, so whenever vertical is false, we will want to apply our horizontal CSS class. Let's go back to the browser and check it out. Our horizontal layout not only now works, but also looks really good. In the next lesson, we will take a small turn and look at how we can handle form submitting correctly in Vue by leveraging the power of a widely used library for making HTTP requests, Axios. See you there. Welcome back! With all the components that we built in the last lessons, we can construct any type of forms. But what good is a form unless we can send the user's input to be processed or stored in our backend? In the current state of front-end development, the most common approach to submitting form data to our backend is through XML HTTP requests, or XHR for short. We'll talk about this more in a little bit, but for now, just know that Axios is a library that will allow you to create XHR requests without having to deal with the vanilla XHR JavaScript API, which can be a little bit cumbersome. There's some form concepts we have to learn and understand before diving into plugging Axios into our application to start making these XHR requests. Let's dig into the defaults of form behavior and some fundamental accessibility concepts first. The default behavior of a form in HTML is to send a bunch of data into a specified URL by triggering a browser navigation event. What this means is that without the use of a library like Axios, your HTML forms will, by default, make the browser load a completely new page. In the age of single-page applications, where we want to provide a seamless navigation to the user without the constant full reloading of pages, this is not a great experience. The second thing you need to consider about forms is every single form needs a wrapping form tag. Screen readers often switch to forms mode when they are processing content within a form element. This gives users that use accessible technologies a better experience when navigating forms, and there is no reason to ever not do it. The third form consideration you'll need to account for is there are many ways to trigger the submission of a form. A user can click or tap into a submit button and click it or hit enter. A user may also hit the enter key inside one of our fields. Screen readers will look for buttons with the type submit type on them. How then do we correctly capture the user's attempt to submitting our form? Whenever a user submits a form with a wrapping form tag, this form tag emits a submit event that we can listen to. And even though it's common practice to set a click listener to the submit button of a form, this should be avoided. Listening to the click event of a button within the form tag and preventing its default behavior effectively blocks the default behavior of an HTML form, which is to submit the submit event, and afterwards sending the data within said form. However, it does not cover us from other possible ways of submitting said form, such as the ones we have learned about earlier. Let's now open up VS Code into our simpleform.view component. As you can see, we already have our submit button set up with the type of submit. Whenever a button with the type of submit that lives within a wrapping form element is clicked, it fires off that wrapping form's submit event. This is the behavior that we want for our forms. You might be wondering, what happens if we forget to add this type of submit to one of our buttons inside the form? Browsers will assume that any buttons within form tags that do not have a set type are meant to submit this form. However, the extra specificity will help accessibility tools to identify it as the button meant to be used to submit our form. If our form required other types of buttons, such as a cancel button, for example, adding the specific type button to it will effectively stop it from triggering the form's submit event. We can now go to our form tag and start listening to the submit event of our form. Let's now scroll up to our form element. We will add a submit listener with a prevent modifier. This will trigger a sendForm method that we will create in a minute. Notice that we are using the event modifier .prevent on the submit event listener. This modifier will call prevent default on the submit event for us, so that our sendForm method can focus exclusively on the logic of submitting our form and not on event handling. Setting prevent default on a submit event for a form element will block the default behavior of having the form submit the data by itself and reloading the browser. We want to keep control on how our form is being processed, and we want to post our data using Axios. So preventing this default behavior is exactly what we need. Now that we are listening to our event, let's go ahead and add our new sendForm method inside the methods block in the script section of our simple form.view component. We will leave a comment here for now, and we will come back to it. In order to be able to capture our users' input once they submit the form within our new sendForm method, we need to first get ourselves set up with two things. The Axios library we discussed in the beginning of the lessons to be able to make our XHR requests, and an API endpoint where we're going to be able to send our dummy data to. Let's start with getting Axios set up. Head over to your terminal on the project root and run the following command to add Axios to your project with your favorite package manager. Once Axios is done installing, we can head over to the top of the script block in our simple form.view component and import the library so that we can make use of it later. Now that we have Axios set up, we need to create an endpoint that will receive our data once the user posts the form. In a real-world scenario, this endpoint will usually be provided by the backend of your application or by a third-party service such as Firebase. For the sake of learning, we are going to be using my JSON server. You can see the URL on your screen now. A free way to create our own fake online endpoint so that we can learn how to post our form. You will already be familiar with this if you've taken our real-world Vue 3 course here on Vue Mastery. Setting up for your own GitHub repos is really easy. Just go ahead and follow the instructions on their website and add a db.json file to the main or master branch of your repo. Then, you can access and use it through the URL structure that they provide as a REST API endpoint. I've already gone ahead and created this for us so that we can use it with the courses repo here on Vue Mastery. The URL for our REST API is shown on screen. When you open the server, you will notice that under Resources, we have events listed. I'm going to click into it. This is our API endpoint for events. I will not go into details of what a REST API is because that is completely out of the scope of this course. But unless you are a full-stack developer and are going to be creating the REST API on your own, the most important thing that you need to know at this moment is that we can grab this URL and make XHR requests to it. In particular, when saving the data from a form, you will almost always want to make a particular type of request, a post request, which allows us to send a chunk of data back to the server with it. Let's swing back to the code and take a look at how to achieve sending our forms data to the REST API with Axios. Let's scroll all the way down because we're going to add an Axios call to our sendForm method. We will remove the comment. We will add an Axios.post call. I will now paste in the URL for our endpoint and add this.event as the second parameter. We will go over this in a minute. We will also add a then block with a console log inside of it and a catch block also with a console log. Since we already imported Axios, we can access its post method directly from the Axios object. The first argument that it requires is the URL onto where it's going to send the information. In this case, the one provided to us for the events endpoint of our MyJSON server mock API. The second argument is the payload, an object containing all the information we want to send over to our server. Since we already have all of the form's information neatly wrapped into our event data object, we can make use of it directly here and just send it as is to the server. Be warned, in a real-life scenario, you will want to validate your user's input before sending it to the server, even if your backend is going to perform server-side validation. Doing a pre-validation on the front end or the client-side validation is a highly recommended practice. In general, any type of pre-checks or UX changes you want to make while the form is posting should be done here in the sendForm method. Displaying a loading spinner or changing the text of the submit button to sending are a few nice UX tricks you can leverage at this stage. Validations and UX are out of the scope of this lesson though, so we are going to skip them for now and revisit in another course for more advanced form topics. An important thing to know is that Axios methods return JavaScript promises. This means that we can append a then method to our post call that will return the response from the server for us to work with, and a catch method that we can use to handle any errors that may occur when sending the data. For the purposes of this lesson, we are only going to console log the results here to see both of these methods in action. Let's go back to the browser now. Now that our submit function is ready, and after we've learned all of that theory, we are finally ready to go back to the browser and test out our form. Serve your project and fill out the form. I've already done it here in the video. Make sure you have your network tab open in your browser so you can see the requests going out. And finally, hit that submit button to see all the information swiftly sent to our API. In the network tab, we can see our successful request and the response mirroring our payload. And in the console, our log with the full response data. That was a lot of theory, but we now have a fully functional form that submits data to our server. There's one more thing though, arguably one of the most important bits of all. A few lessons ago, I mentioned that our components were not accessible. And while in a real-life scenario, accessibility should be a main consideration while developing your components, it simply was too much information to put on top of our previous lessons. We are now ready to circle back and take a look at some basic accessibility concepts that you should always keep in mind when building forms in Vue. See you there! Welcome back. At the end of the last lesson, we discussed the importance of incorporating accessibility into your first round of development. I cannot stress this enough. Accessibility is not a secondary task that you come back to after your app is working. It is a primary concern that needs to be addressed as part of your development process. In this course, I decided to keep it separate for educational reasons, introducing one concept at a time and building upon those concepts incrementally. We now have the conceptual groundwork laid out to add in our accessibility features. We will go over what I consider some of the very basic accessibility concepts that you need to keep fresh in mind when developing forms. These concepts are technically not Vue specific, but we will learn how to apply them in the context of our Vue form components. Let's dive right in. Let's take a look at using appropriate types. In HTML, we have a wide variety of input elements to craft our forms, but one element in particular rules them all. The catch-all input allows us the flexibility of creating text inputs, but we can also transform it into checkboxes and radio buttons with the type property. A common mistake is to ignore this type property when creating text inputs. Most of us know and commonly use two regularly: type email and password. When using a specific type in an input element, not only do we get better autocompletion for our form, but it also allows screen readers to better understand what type of data we want to retrieve from the user. A type of tell, for example, will provide the user on a mobile phone with a handy numeric keyboard with phone symbols like plus, asterisk, and hashtag. Your users with mobility problems will definitely be grateful for this one. Bottom line, don't forget to set your type, even when the input is not of type password or email. Here you have a list of available types for an input element. Let's now move on to the use of field set and legend. Two often overlooked or undertaught elements in HTML are field set and legend. In forms, usually we group our inputs logically. For example, you would usually code your form to first ask the user for their personal data, like name and phone. Later on, another section may ask them for a shipping address. For accessible users, this information may not be as immediately available without having to tab through the whole form. This is where field set and legend come to play. You should always try to wrap up sections of your form inside a field set element. This will logically group the inputs inside of it. Then, the first element of the field set will be a legend element, which will provide a title for that particular field set. If for some reason you do not want the legend to show on your form, usually because of some design reasons, you can always position it absolutely outside of the visible screen. For our current form in simpleform.view, we can wrap up our logical sections inside field set as follows. Let's take a look at simpleform.view in VS Code. I'm going to add a field set element. Inside, we are going to copy the two inputs and the h3 tag. This h3 tag will now become a legend. Let's do this one more time. For the events section, I will cut the inputs and the h3 tag again, and it will become once again a legend. Let's do this one more time for the pets section. I will copy once again the h3 and the div into the field set. And you guessed it, the h3 becomes a legend. One more time for the extras. We create our field set. We're going to cut the h3 and the inputs, paste it inside, and switch the h3 for legend. One more thing though. I want to go back to the pets section. We are going to replace the legend with pets. And the "Are pets allowed?" question I will put in a p tag to better signal what we expect from the radio buttons. Finally, we can scroll all the way down and add a style tag. We will remove the default borders and margins. First, we will add a field set tag and set the border, margin, and padding to 0. Next, we can style the legend. We will set some values here for the font size of 28 pixels, the font weight of 700, and the margin top of 20 pixels. This will make the legend tags look as our previous h3 tags. We can now go see this in the browser. I'm going to be using Firefox this time because it has a very nice accessibility inspector tool. If we go and check the accessibility tab, you can now see how the logical grouping of our form will be understood by screen readers. We're getting 4 groupings, each for one that we just created, and you can see that as I hover over them, they get highlighted on the left with purple. Each of these groupings represents one of our field sets. Our next step is do not rely on placeholders. A popular design pattern that emerged a few years ago used the placeholder attribute of inputs to describe the type of content that the element was expecting. Sadly, this is still sometimes used nowadays instead of a proper label. Placeholders should only be used to describe the intended value. but not as a replacement for a descriptive label. Placeholders disappear whenever a user starts typing into the field, forcing the user to keep in mind what the field was expecting. Additionally, some users can have problems differentiating between a field with a placeholder and a field that has a pre-populated or filled content. As far as screen readers go, each screen reader may treat the placeholder attribute a little differently, but as long as a correctly set label is in place, it shouldn't be much concern to leave it in. Let's talk more in detail about labels. A really powerful accessibility feature that is sadly very commonly underused or misused in forms is labels. If we navigate here to Firefox again in the Accessibility tab and inspect our title input, let's take a look at the information panel. The check section is already telling us the issue. Form elements should have a visible text label. This may come as a surprise, since our title field clearly has a label on top of it describing what we intend for this input. For our sighted users, however, this is not evident. We have not yet linked these two HTML elements together, and that is an assumption that a screen reader cannot afford to make. Thankfully, this is a very easy fix. There are a few ways to link an input element with its label. The first one is to actually nest the input inside of the label element, like this. This is one of the easiest ways to make sure that your input is always correctly linked into the related label, but I want to go into detail into the second and usually more common way to relate HTML elements, because it will come in handy later when we look at error messages. This method involves using IDs. Let's jump directly into our base input component and figure out how to create a relationship between our label and our input by using an ID. You may be thinking that perhaps the most obvious option would be to add a property so that the parent can determine the ID of the element, and then we don't have to worry about it inside our component. And you would be right. But what if there was a way we could dynamically generate unique number identifiers for every component in our form without having to resort to manual props? We are going to create a Vue3 composable that allows us to create dynamic unique identifiers, or UUIDs for short. I know this is a bit of a jump from the pace of this course, but if you need a refresher on Vue3 Composition API or composables, we have a course titled Build a Gmail Clone with Vue3 here on Vue Mastery that will get you up to speed. At any rate, don't worry too much, it's going to be a really simple one. If you're following along with the repository files, I've gone ahead and created a uniqueid.js file inside the features folder. Let's take a look. First, we declare a let variable with a default value of 0. This will increase as we create more and more components. The first component will have an ID of 1, the second of 2, and so on. We are going to export a function, uniqueID. When executed, this function will return an object, which contains a function under the property getID. This function will increase by 1 the global UUID counter and then return it. Know also that there are plenty of UUID libraries out there that you can use in place of this custom solution, but I wanted to show you just how easy this can be. Let's look at this in action to better understand it by looking at baseinput.vue. First, we are going to import our new composable. Import uniqueID from features uniqueID. Now that we have it ready, we can generate a new uniqueID inside our component's setup method. Let's go ahead and add the setup method here and declare a constant of UUID. We will call the uniqueID method and the getID method inside. Notice that we are executing both the uniqueID composable and then the getID method inside. This will give us a completely unique ID number every time the component is instantiated. Finally, we return an object with a UUID so that we can use it in our template. Speaking of which, let's go back into the template and tie the label and input together. To accomplish this, we need to give the input element an ID attribute value. We will bind the ID to our UUID. After we have the input set up with its own unique ID, We can now tell the label that it's describing the input by setting the for attribute of the label. Please note, all of these are vanilla HTML attributes. There's no crazy view magic here other than the ease of binding all of them. Let's head back to the browser. The first thing I want to point out to you is that the warning sign on our field is gone. And if we check under the bit where it says Relations inside the accessible properties, we can see now that it shows a new entry, labeled by Title. If you hover over this element, you can now see in the browser which element exactly it's referring to. Neat, right? Now, if we take a look at the Inspector tab and we look at our input elements, we can see that they have automatically been assigned IDs 1 and 2 respectively. We still need to add a UUID to our checkbox, radio, and select components. Are you up for this challenge? Try doing this bit yourself. It will be as straightforward as replicating exactly what we just did here with the base input. Let's talk now about accessible errors. Have you ever filled out a form just to hit the submit button and nothing seemed to work? It was clearly not submitting and there was no visible error anywhere, yet something was clearly wrong. This situation is not foreign to most internet users, but imagine the exasperation when you require accessible tools and the form doesn't easily tell you what's wrong with your inputs. Let's go into our base input.view component and add a new prop, error. This will allow us to set a string with an error message in case the component is in an error state. It will be a type of string and a default of an empty string. We will display this error below our input field whenever an error is present. So if the error property is set to anything other than an empty string, we will check this condition with a BF and we will add this class of error message so that it shows red. Finally, we interpolate error on our p tag. We will also go back to simpleform.view and add a demo error message to our title input so that we can see how it behaves on the browser. Let's add our error property and it will read, "This input has an error." Now let's look at the browser. The error is correctly displaying under the title once the error prop is set. Note that the description input, which is also a base input component, is displaying no error because the prop error is not set to anything. If we open our Accessibility tab in Firefox once again and inspect the input element, we can see that there is nothing tying the error to the actual title input. This is where most forms fall short. Just because the error message is near or close to the input doesn't mean that a screen reader will be able to identify it as part of the error. Luckily for us, there is a straightforward solution to this problem: the ARIA described by attribute. This attribute allows us to declare directly on the input element which other elements describe it. The attribute can take a string list of IDs for other HTML elements in the page. So first, we're going to add a unique ID to our label. Luckily, we already have a UUID number associated with the instance of the component to be able to do it. Let's head back to base input. We are going to add an ID binding to the p tag. Notice that we're appending the -error string to the UUID. We need this identifier to be unique, and the UUID by itself is already in use by the input. Now that our error message has a unique ID, we can set it as the description for the input element with the ARIA described by attribute. Notice that we are adding a secondary check to see if error is set. This allows us a bit of a relationship hygiene between our elements. When no error is present, no error message will be displayed and the ID will point to nothing. If we check our browser once again, we can see that when the error is present, a new described by entry is present in the inputs relationship object. Notice that when we hover over it, it also gets marked in purple on the browser. One more thing though. Because we are using BF to display this information on and off, we want to make sure that screen readers announce or read it whenever it becomes displayed. To do this, we are going to add an attribute of ARIA Live assertive. Another way would be to add a role attribute of alert, but I've found that ARIA Live tends to work better with a variety of screen readers. Let's navigate again to our base input.view and let's add an ARIA Live attribute here on the P tag with the value of assertive. Let's now talk about explicit input state. Yet another thing we can quickly add to our input to make it even more accessible is the ARIA invalid attribute. A mistake that I've seen many forms make is to try and rely on a red border around an invalid input. For obvious reasons, this is not accessible. We've taken already steps into accessible errors, but let's make sure to also notify screen readers on the invalid state of the input to provide better feedback for our users. We are going to add the ARIA invalid attribute to our input and toggle it off and on depending on where the error property is set. When the input is valid, null will make it so that the attribute is not added to the input element. Let's go back to our component baseinput.view. Add the new ARIA invalid attribute binding to the input element and we will check. If there is an error, it will be true. If not, it will be null. If we go back to the browser and inspect the input using the accessibility tool on Firefox, we can see that the state of invalid has now been added to the active states of the input. Other noteworthy states that we could also add attributes for are read-only, disabled, and required, displayed on the left. These three can be set directly with HTML5 attributes of the same name or with their ARIA counterparts on the right: ARIA read-only, ARIA disabled, and ARIA required. One more tip: do not disable the submit button. If a form is valid, then it makes sense to set the disable attribute to true on the submit button so that the users can submit the form, right? We can even style the button with a different color to convey that it won't be clickable. There is a big problem with this though. Users that rely on screen readers will not get any feedback at all. The button will be completely ignored by the screen reader when tabbing through the form. This clearly can be very confusing and frustrating. I suggest instead that you make any and all checks to make sure your form is valid before submitting it on the send form method that we created on the simple form component. If everything checks out, we submit the form normally. If something is wrong, then set the necessary errors in your forms with the tools that we just learned to notify the user that something is wrong. Please note that this is pseudocode and these methods don't actually exist in our code. As you can see, with a few quick lines of HTML and some strategically placed properties, we managed to turn around our base input component into something a lot more accessible. I do want to stress though, that as far as the topic of accessibility goes, this only begins to scratch the surface. But with these few goes, this only begins to scratch the surface. But with these few tips, you should be able to set the course for more inclusive and accessible forms for your projects. Thanks for watching.